Hello everyone. We will in last lecture we was discuss about the steps involved in a methodology of the design. Okay. So today we will discuss a morphology of a design, how the design can be do with the morphological way. So morphology means a study of a form or a structure. The morphology of design refers to the time-based sequencing of the design operations. It is the methodology of design by which idea about things are converted into the physical object. The logical order of the different activity or the phases in the design project, or you can say product, is called as a morphology of a design. The design project goes through the number of time phases, and morphology of design refers to the collection of these time phases as it put forwarded by Morris can be elaborated as per the given flowchart, which is shown in the seventh phases in figure number 2. First one, uh, feasibility of the feasibility study. Second one, a preliminary design, detailed design, then planning for manufacturing, planning for distribution, planning for use, and last one is a planning for retirement. Okay, we will elaborate one by one. First one, feasibility study. Actually, this is a stage where whatever the design concept is we are using, it should be, we have to judge that it should be feasible, or whatever the concept or innovative idea which we carried out, it should have a different solution. We have to find out the various aspect of that product. Then we have to narrow down to the basic concept, because in feasibility study again there is a requirement of great creativity involvement, innovations. Then there are few most uncertainties are available over there. Also we have considered this product or project with respect to business point of view. So these are the various aspects. Also we have to find out the uh, evidences, so that it can says that whatever the idea what we have using, that idea is very solid, and it need to be go for डिज़ाइन. ओके, तो आपको वो आइडिया यहाँ पे कंफर्म करना है. If it is prove that this kind of work has isn't be done, or whatever the product or project you are doing, it can be useful for the end customer, society, or any uh, consumer. Okay, so it whenever it satisfied this first stage, then our idea is goes for next design, next step. Okay, also we have to evaluate its economical aspect, its financial aspect, then physical reliability, it should be the reliable one. Then we have to also consider the uh, customer point of view. Whenever this project is launched or product is launched, the first customer should able to buy. Okay, so based on the need, you have to identify the whatever the need you have identified, whatever the need, problem, or the modification that you have considered, it should be feasible one. Okay, next one, preliminary design. Now in the stage at which the concept is generated in the feasibility study is carefully developed. Basically, structure developed of the design concept occur in engineering design phase. It is the place where flesh is placed on the skeleton of the design concept. The embodiment of all main function that must be preferred by the product must be undertaken. Just we have to take down the list. It is it is in this design phase that decide are things like strength, material selection, size, shape, then any special information that could we have to note down, aesthetic looks, then so such kind of things we are enlisting over there, and some important activities that must be done in this stage are model building and testing, study the advantage disadvantage of different solutions, and check the performance, quality, strength, aesthetic looks, and etc. So that your product is in could be ready in a preliminary stage, or you can say embodiment stage or a design. Okay. Third stage, detail design. Uh, it is actually in this stage. Actually, we have already basic design has been done in phase number two. Now we have to refurnish the complete engineering description of the tested product. In this phase, the design is brought to be the stage of complete engineering description of that whichever the product we have tested before. Okay, in previous stage, and also we have to find out the productability of the product. Any missing information is added, and also it could be arrangements, forms, dimension, tolerances, surface properties, materials, manufacturing process. These all parameters are finalized with a particular sequence, with a particular process. This result in a specification of each special purpose part, and for each standard part to be purchased from the supplier, and finally we can complete the prototype is tested. So also we have to enlisted which part should be a standard one, and we can adopt these or purchase these parts directly from the customer rather than manufacturing. If you consider nut and bolts, these are very low in price, and the time consuming to manufacture is very high. So that's why we are purchasing, and the standard formats are standard things are available in the market. So that's why we directly go for purchasing of these such kind of products, or you can say such kind of parts. Okay. uh, at the end, what we are doing, we are preparing the process sheet in this design stage. uh, we are doing few things such as basic designs, then dimensioning the part which is skip from the preliminary design that we are adding, and manufacturing process which we have to do, that we are deciding. So every decision making has been done in phase number 3. Next one, phase number 4. This includes all the production planning and control activities which is necessary for manufacturing of the product. So we can say stage 4, it name itself planning for manufacturing. It gives the idea what we are actually doing in this stage. Okay. So detailed planning must be done to provide a product, or you can say a production guy or production department, so then they can manufacture the component, product or part very easily. Okay, a method of manufacturing must be established for each component in the system. As usual, first step, the process sheet is created to manufacturing any component. It contains the sequential list of manufacturing operation that must be performed uh, in the component or any components. Then second stage, we have to specify the condition of raw material. So raw material could be uh, a steel bar or any bars or any what kind of sheets, any casting. So this raw material condition we have to identify or specify. Then also we have to specify the tools and machine required. So as per the component, we have already prepared the process sheet. So in the process sheet, we have to decide which type of operations could be performed to complete the manufacturing, to complete manufacture of that part. So in this, before manufacturing, by selecting the close tolerances and all the conditions, then surface finish, these parameters should be considered for manufacturing, and according to that, you have to find out the tools necessary to achieve these conditions, and also type of machines also you have to specify. Next step, estimating the production cost. It is a very important task again, because if the production cost is too much high, it is not viable for the customer to buy, or it is not in a budget of the customer to buy. Then the product is totally what you can see, vestige with respect to the business. Okay, so carefully you have to calculate the cost of manufacturing or product, plus the other costs are included inside, so that material handling cost, then any outside purchasing cost. So these are the basic costs which can be included inside the plus profit, so that you can directly find out the product cost. Next step, specify the requirement of the plant. Okay. Now next, very important, if I have to establish a plant where the all processes are in-house. So if these processes are in-house, I'm not dependable upon to any other manufacturer, other so that my continuous production is going on. As my continuous production in a batch size, or can see a very large size or any huge size can be done, so the manufacturing cost automatically goes minimal. So that's why you have to specify the plant requirement. What could be the machines, what could be the process, what are the requirements, so that have to specify over in this stage. Next stage, planning for quality control system. Now, whatever we have manufactured, we must have to understood, or we have to must check that the quality we are promising to the customer, that should be fulfilled, and the dimensions are which we have um, specified in a design, that should be meet properly. So for that, the quality control, it could be a stage wise, it could be assembly wise, it could be a final testing, then surface finishing. So better quality control process to avoid the waste of the component or rejection rate, you must have to check the quality and dimensions in a process itself. so that the minimum, if any correction is required, it could be done in a particular process itself only. Otherwise, when the final product is generated and you are going for a checking, and if there we found that this thing is a uh, under dimension, or which is not suitable for the whole assembly, then we have to re-engineering, or we have to track all the process, then we have to check again and again. So it is very tedious and difficult task. So avoid such uh, problems. You have to plan a quality control checking in every stage and after each process. Next one, planning for production control. As I say, when we plant, uh, prepare a planning for plant. So in a plant, if we manufacture in a huge batch size or huge lot size, the production cost of the product is get reduced. Now we have to control all the aspects, that the feasibility of that product or production control. In a production control, what we do, whatever the lot size or batch size which can be done in a single shift. There are generally three shift working, maximum three shift working is available. So most of the companies, when they start their production, they can work in a three shifts. So we have to consider, we have to uh, give the target to the manufacturing, what you can say, line, for to creating a maximum number of component in a one shift, or that is in a 8 hours. So everybody's, the design engineer or production engineer studies the time required for manufacturing the single component, and based on that, they specifies the production quantity in a shift wise. It's not a day wise, it's a shift wise, so that they can easily control that in which shift the production is higher or production is lower. So all these aspects could be planned in the this stage. And last stage, the planning for information flow system. So here you have to plan that if any problem or any mismatching is happen over the shop floor because of the design, that information should be conveyed back to the designer, so that the designer can be changed the modified or modified version, and that modified version has that eliminate that drawbacks, and again move forward to the production line. So this continuous loop has to be managed, so that the quality of the product, with or we can say probability of, or you can say efficiency of that component product would be a great one or a maximum one, so that this continuous flow of information could be circulated, or you can say in a single loop it could be happened. Otherwise it is very difficult to um, maintain the quality as well as the uh, what you can say faith of customer of your product is get lost. Okay, if it is not proper. Okay, so next phase, the phase number 5, planning for distribution. It is again very important. If you plan properly, if you're manufacturing that computer, that product is very uh, as per the given design, everything is done. But now the economical success of any design depend upon the skill exercising in a market. Hence, hence in this phase, at the planning and effective distribution system, the important technical and business decisions must be taken, and it made to provide the effective distribution to the consumer of the product that have been produce. So we have to uh, consider, or we can say plan according to the distribution with aspect to the technical and business consideration. In the strict realm of design, the shipping package may be critical. The concept such that the shelf life of the product may also be critical, and many need to be addressed in earlier stage of the design process, as I discussed before. Also, if any problem occurs with respect to the end customer, that should be tackled during testing and all the HR in all process, and that could be converted or modified in a design itself, so that the end customer will be happy. A system of warehouse for distributing the product may have to be designed if there is no if not existed previously, or you have to plan to buy on a rent such warehouses, so that whatever the component we can manufacture, that could be stored in a particular warehouse, and from that we can easily distribute to the market. If the consumer product, the sales effort is concerned, or advertising in a printing, video media, but highly technical products may require that the making step be a technical activity supported by the specialist sales brochure, performance test data, and technical trained sales engineer, so that we can provide the proper advertisement. For example, you watch the ad of any bike, what they shows the how much cc it is, what is the mileage, what should be the cost, then what technology they have used, and how the bike is very essential to the customer. So this technical data, as well as test drives, a lot of things they can share with the customer, but depend which type of data should be or could be shared with the customer. Okay, so that is a simple example which you can understood about this. Then a few different activities has been done in this phase are designing the package of the product, planning the effective and economical warehouse system, planning for advertisement technique, and designing the product for effective distribution in the previous condition. So these are the basic what you can say outcomes of this phase. Next one, phase number 6, planning for consumption or use. The purpose of this phase is to incorporate in the design all the necessary user oriented features. The use of the product by the consumer is all important, and considering of how the customer will react to the product in all steps of the design process. The following specific topic can be identified as the being important user oriented concerns in the design process, that those are such as ease of maintenance, durability, reliability, then product safety, convenience in use, that is a human factors which we are considering in engineering, aesthetic looks, and economical of operation. Also, the when we considering the consumer oriented issues must be considered in the design process itself at very beginning. They are not considered as or you can say we have to must uh, goes thoughtful process in in a beginning stage only. After, it is very difficult to um, cover up all these things. So various steps summarized in this phase are design for maintenance, design for reliability, design for convenience in use, design for aesthetic feature, design for prolonged life, and design for plant a product improvement in the basic or service data. Last stage, that is planning for retirement. In this phase, which takes into account when the product is reached the end of useful life. The final step in the design process is the disposal of the product when it has reached the end of its useful life. The useful life may be determined by actual deterioration and the wear to the point at which the design can be no longer function, or it may be determined by technical observations in which the competing the design performance the product's functions either better or cheaper. In the consumer product, it may come about the various changes in a fashion or taste. So we have to always modify the design aspect. Okay, so always we have to find out the upgraded versions so that customer could not change his taste. So the basic stages which we are perform in this phase are it does not function properly, sorry, design of several levels of use, design of reduce the rate of obsolescence, then examine service terminated products to obtain useful informations. Okay, when product may be retired, it could be retired when it does not perform its function properly. Then another competitive design and merge two, three, what you can say, sub models of our product so that the multifunctionality could be the problem, change of taste or fashion. So these kind of things could be occurred, and because of that, the product could be get retired. Okay. Now next one design type is a optimum design. Now in an optimum design, there are few what you can say design parameters which we have to classify. First one is a functional parameter. These are the condition imposed by the end application on the component. These are the requirements which are must be fulfilled to perform or to what you can say to pure function of that component. Generally, the function requirement parameters are independent of the material and geometry parameter. So, second one, material parameters. The material parameters are those parameters which describes about the material values like density, modulus of elasticity, modulus of rigidity, yield strength, ultimate tensile strength, then cost per kg, and then and etc. Third design parameter is a geometrical parameter. These are parameters which define the limit of the geometry of mechanical component, such like as a module of gear, length of belt, face width, etc., etc. So it can be define a particular dimensions and the basic tolerances and all things. Okay, so these are few design parameters which we have considered in an optimum design. Now, what are the desirable and undesirable things in an optimum design? So, functional requirements are the conditions which may be satisfied with the mechanical element so that the works can work as intended. So, few desirable effects or undesirable effects of the optimum in optimum design we will discuss now. Desirable effects. The desirable effects are the function required parameters that are useful for the mechanical element to perform the satisfactory level of its function, like tensile strength, power transmission capacity, storage capacity, bending strength, etc. These desirable effects are the best when they are maximum in value. Second thing is undesirable effect. The undesirable effect also the function required, but they are a detrimental for its function and are the best when they are in a minimum value, like a weight of component, cost of component, imbalance in a component, etc. etc. So, for the design problem, a large number of solutions are available, which is basically fulfill the function requirement. The optimum design helps to choose the best alternative of the all available by keeping a certain targets in the mind, like a minimize in a weight, maximize in a strength, minimum in the cost. So what we can say, the main objectives of the optimum design is select the best possible option from the available alternatives, keeping the target of maximum a desirable effect or minimizing the undesirable effect. Or you can say to reach the best solution without doing a repetitive work of the detailed analysis and evaluation of each alternative, that is called, if the optimum design method would not be there, we would have to design a complete component considering each alternative material, and we have to take a laboratory work or you can say experimentation. So that could be avoided by using optimization method. So optimization method is developed in optimization method. There is a Johnson's method is available. Optimum design. The Johnson's method is available. Uh, the Johnson's method gives the desirable process, and also they have provided few things so that we can find out the optimum design values. So there are three equations they have enlisted. Based on that, they have designed few steps. So when we perform these steps, we can get a optimum combination of all parameters. So first parameter, or you can say first equation, that is a primary design equation. It is the most important equation which outlines the most significant functional requirement to be maximized or most significant undesirable effect which to be minimized. For example, in the design, the tensile strength of the bar is the primary target of the minimum weight. If weight is increases, automatically undesirable parameters such as unbalanced forces can be increased. So we have to consider and prepare a equation which can be uh, takes care of this condition, and the equation for weight is primary design equation, that is we can consider call as PDE. Secondary design consideration, that is SDE. This is the secondary or design equation are the important equation other than the primary design equation. For example, in case of tensile bar, the design equation of the tensile stress is the secondary design equation. So rather than consideration of the few other parameters, uh, we can prepare a sub design, or we can say sub equation that should be that should be elaborated in secondary design equation. Third one, limit equation. The limit equations are important design equation that define the satisfactory range of the design parameters, certain design parameters. For example, limiting value of stress, cost. Then cost is a parameter which is depending upon all. We can say torsional stiffness, or you can say toughness. So these are the parameters which we can limit it. If we manufacture more tough, we need a good quality material, and which could be increases the cost. So optimum value will give us based on the customer requirement. Okay, to so Johnson's method that could be give us the optimum design process, which follows the 11 steps. So we will discuss one by one. First step is select the independent geometrical parameters. So in this stage we have to select which are we have to identify independent parameters and which are the dependent parameters. So out of that we have to select independent parameter. Second, decide the basics of the optimum design. So here we have to decide which things we need to be optimized, such as weight, cost, strength, etc. Then we have to write primary design equation. In stage number 4, we have to write secondary design equation with the limit equation, so that whenever we get a solution, that could be the optimum one. Then we have to classify the parameters. Next step, we have to combine secondary design equation with the primary design equation, so that by using various optimum design methods, we can find out the most possible solution. Then find the variation of optimum design quantity. Okay, so here we can find out various different combinations. Then again we have to impose the limit equation on primary design equation, so that it can be filtered more and more. Next, they write out the primary design equation in terms of parameter groups. Then select the optimum material from a comparison table of various materials, and determine the optimum value of geometrical parameters. So it could be give the optimum values of available things, so that without doing a experimentation, we can find out the exact values. How, what is the advantage of this optimization over the experimental design? In experimental design, each and every time we have to prepare a product with alternative materials and find out the testing data, so that the statistical things, or you can say experimentally, the cost of experiment get increased, and it could be increase the time which we consuming. In optimum design, you can directly find out the best possible suitable condition. or combinations, so that you can using the most and best things in your product. Okay, and the design uh, also we can do with the mathematical process and contain or limiting the unfeasible parameters, so that we can do whatever that could be mostly feasible things. Okay, uh, in our first module, this is the last point which you have to consider now discussing the system concept in design. Actually, whenever an engineer gives an a design problem, it has to be solved it by the applying a logical or innovative concept, the concept which will lead the way and the direction to take the decisions. In concept design is an important phase of the design process. It asks designer to consider all the possibilities of the design before before zeroing down to any one. So in other words, we can say it's a innovation without limitation. The basic principles to use of concept design and the steps which we have shown: innovative idea, product requirement, concept design, design finalization, prototyping, and final product. So basic principle behind this are using the CAD software for shaping the idea, or using the CAD model you can draw a 3D model, or whatever your idea is, you can rather than manufacturing or doing it, you can easily prepare in a CAD model. Then you have to find you have to test the basic analysis on the that CAD model, so that the experimentations could be reduced, or the cost required for experimentation get eliminated, and it gives the result analysis very early as possible. Then collaboration with the colleagues and customer to collect the inputs and suggestion, so you can continue work on continue improvement process. Then also get a particular feedback from the customer. So what are the things, or we can say what problems he faces while using the product, so that based on that information you can identify the segment where we can do uh, modification, do that modification, and again launch the another version, so that the customer will be happy. So our final aim or goal to manufacturing any component or product is customer satisfaction. Okay, so this is all about the model number one. If you have any doubt, you can personally WhatsApp me or call me. Okay, so thank you everyone.